Hello guys, thanks and welcome to my video tutorial. My name is Ekeu-wei and I'm a PhD student at Lancaster University. So today I'll be talking to you guys about how to fill missing data and hydrological time series with altimetry data. By the way, I'm also a freelance consultant at Ekeu-wei Technical Services in Nigeria. In case you have any interest in anything, you can always hit me up or email me for any inquiries. All right, I've actually put up a couple of videos out there on missing data in hydrological studies because I've been facing a similar challenge as part of my study. So today I'll be talking on something very particular, which is filling missing data using Altimetry, which I've seen to be one of the best methods out there. So what this does is we take in situ measurements from the gauge station and we take altimetry measurements from virtual altimetry stations that is derived using remote sensing. So we combine these dates that we have measurements available for both the in situ gauge station and the virtual station, and we use correlation equations to be able to extend the in situ measurements for days where we have altimetry and we didn't have in situ measurements for. That's clear enough. Also, the interesting thing about altimetry data is that they have different missions up there. So T and P here stands for Topex and Poseidon, then MVSAT, then JSON2. So the continuity is quite interesting. This week, JSON3 is going to be launched, and we're expecting a SWOT to be launched in 2020, which is going to be like one of the best because it's going to be capturing water level and discharge at the same time, hopefully. And Sentinel-3 should be launched this year or early next year. Not too sure, but yeah, it's going to be launched soon. So when we have that, then we've gotten water level measurements. So already for the gauge stations, we should have the rating curve and equations available, else we won't be able to use this method. So in-situ measurements and in-situ discharge is what we use to derive rating curve. So if we impute the data that we've gotten from the extension into a rating curve, we can now derive what the peak discharge is. So it's as straightforward as that. So I'll go straight ahead and show you where the source of the data comes from. So there are actually different sources out there, but I'll just show you this straightforward one. Is this site right here? I think it's a French site, but my system just does a conversion. So so when you open that, it actually looks something like this. So it's quite global. So there's North America, South America, Europe, and everywhere. But I'm working in Africa and I'm working on the Niger Basin. So these green dots here represents the stations, and these are the tracks where the satellite passes and establishes these measurements. So that is for the Topex, and this is for the JSON2, and this is for MVSAT. So I have stations all around this area, so which is quite interesting. So if you're working on any other place, yeah, I think you're going to also have some stations available either upstream or downstream of your station. So when you download that data, just go around the site and try to familiarize yourself, but you have to fill in an application and they're going to send you a password on how you can download the data. It's free, so you don't have to spend any money on it. But when you download the data, it comes as a text file. So most times it looks like this. So this is the dates, and that's the water level, and that's the standard deviation. But the interesting thing about the date is that it's a decimal date. It's just like the first time I saw it, but it's actually an interesting way to convert it. So I used this slide. I was trying to go through R and other codes and stuff didn't just work out even on Excel. So I found this beautiful site, and I'm just going to introduce you guys to it. So what it does is you can get the date. It's like 2015 2.33. No one knows what that means. And if you click on the convert, it just converts it and tells you that that is 27th of March. So you just copy this out and just use it. If you can write a program, then you can automate this process. But I don't really know how to do that at the moment, so I just do my thing manually. So, but if you have a whole lot of data, that's going to be quite some stress. So when the data comes into here, then you can now look for dates where you have both data available for the virtual station and for the in-situ measurements. Then relate those two data together and you'll be able to get kind of beautiful plot here. And you have a correlation equation there, which is like this is actually a linear relationship. So yeah, then anytime you have an altimetry extension, you input it there and you get what the in-situ measurement for that time was supposed to be where you don't have data. So it's as straightforward as that. So when you get all of that and you spread it out beautifully, you have something that looks like this. So this is the MVSAT and JSON measurement up here, and this is the in-situ measurement that was available. So this is this one here. So it's just that brief area, and like I use that to extend with JSON to extended that way, and with MVSAT I extended backward. So like I use data from like 2012 to 2011 to create a relationship, and I filled the missing data backward, which we didn't have before, which is quite interesting. But one important thing you should notice that the vertical datum for the ray altimetry and that of the in-situ measurement is different for my study. It could be the same for yours, but so the altimetry comes in EGM 2008, while the gauge station measurement come in means level. So you have to do that conversion, and there's actually a site for that. So I'll just take you to that right now. And this is it. So if you know what the coordinate is for the gauge station, which is provided as part of the data, or for the Vector station, so you just put that in here. You see EGM 9 and 19.5014. Yeah, so if you apply this beautiful formula down here, then you'll be able to put both data in the same vertical datum. It's very important as you overestimate your water level, so you should take note of this very well. So you put the data into this rating curve beautifully here. If you have a discharge water level of like 10, you put it there, project there, and you have about maybe 14 or 13,000 for discharge. And yeah, so you just input it into this formula here, which is this is actually a quadratic formula. So you input the data there, and you're able to get the discharge. Hope I'm not too fast, but I don't just want you guys to spend too much time on this. So you can always rewind back and look at that. So with that, you have all this beautiful data here, and sincerely, altimetry is better than multiple imputation, which I've tried before, because multiple imputation overestimates the discharge. So you can see this red points here, you can see this green point here. The green points are for the altimetry, and this is for the multiple imputation. Because if you have data available for like here, and you have data available for like here, and you do a multiple imputation, it just kind of simulates and averages the whole thing. So it doesn't really correspond to what the hydraulic situation was like for that time. If there was a low flow or there was a high flow. So this looks like the kind of low flow, and it's actually not so low, but it's everything with the simulation just overestimates, while the altimetry technique brings it out back. This is actually the data for this side. It's actually different result, but I just put it out there to just show, because it was really evident there, so I just put it out there to just show you. Let's show you what it looks like. So yeah, so this 8 minutes already, so I hope you guys enjoy the video. Try it, put your hands on it, put your hands to work. If you have any challenges, email me. I'm very much available. All right, okay, thanks guys, and bye.